Nuclear energy is a type of energy released by protons and neutrons in the nucleus, the atom center. This type of energy can be generated in one of two ways. One is the nuclear fission, in which the atom nuclei split into several pieces. The other is when the nuclei fuse together, that is, nuclear fusion. Nuclear fission is the method used to generate electricity around the world today, while fusion technology is still in the research and development stage. What exactly is nuclear fission? Nuclear fission is a reaction in which an atom's nucleus separates into smaller nuclei, two or more in number, releasing energy in the process. When a neutron strikes an atom of uranium-235, the nucleus splits into two smaller nuclei, such as a krypton and a barium nucleus, as well as two or three neutrons. These extra neutrons will collide with other nearby uranium-235 atoms, splitting and producing more neutrons in a multiplying effect, which in a fraction of a second will cause a chain reaction. Energy is released every time the reaction takes place, in the form of radiation and heat. In a nuclear power plant, the heat can be transformed into electricity in the same way as from fossil fuels like coal, oil and gas is used to generate electricity. Nuclear reactors and other associated equipment inside the nuclear power plants confine and control the chain processes that produce heat through fission, which are most typically powered by uranium-235. The heat causes the cooling agent in the reactor, usually water, to warm up and produce steam. The steam is then sent to turbines, which activate an electric generator, producing low-carbon electricity. Uranium, enrichment and disposal. There are multiple naturally occurring isotopes of uranium. Isotopes are versions of an element with different physical and mass properties, but the same chemical properties. The primordial isotopes of uranium are uranium-238 and uranium-235. Uranium-238 makes up the majority of the world's uranium, but is unable to produce a fission chain reaction, whereas uranium-235 can produce energy through fission, but accounts for less than 1% of all uranium. To make uranium undergo the process of fission, the amount of uranium-235 in a sample must be increased by a process known as uranium enrichment. Once enriched, uranium can be used as nuclear fuel in power plants for more than 3 years, before becoming radioactive and needing to be disposed of according to strict criteria to protect people and the environment. Used fuel, also known as spent fuel, can be recycled into different types of fuel for use in particular nuclear power reactors as fresh fuel. What is the nuclear fuel cycle? The nuclear fuel cycle is a multi-step industrial process that uses uranium to generate electricity in nuclear power reactors. The cycle begins with uranium mining and concludes with nuclear waste disposal. Radioactive waste. Nuclear power plants generate waste that contains variable quantities of radioactivity. Depending on the level of radioactivity and the goal, they are handled differently. Only a small percentage of all garbage is radioactive. It's a byproduct of millions of medical treatments each year, as well as agricultural and industrial applications that employ radiation, and nuclear reactors that generate around 11% of the world's electricity. Nuclear power facilities in the next generation, also known as innovative advanced reactors, will produce far less nuclear waste than current reactors. By 2030, they are projected to be under development. Climate change and nuclear power. Nuclear power has a low carbon footprint because, unlike oil, coal or gas-fired power plants, nuclear power facilities almost never emit CO2. Nuclear reactors produce over 1/3 of the world's carbon-free electricity and are critical to achieving climate change objectives. If you learned something new, make sure to share the video and hit the like button. Subscribe for more daily content like this.